Hello everyone, in this video I'm going to do a review of exponential function derivatives and the derivatives of the logarithm functions. So let's go ahead and start with the exponential functions first. So I'm going to write down the exponential function y equals e to the 2x squared plus 3. Okay, so this is our exponential function with the base is e, which is the base of the natural log. So we're going to take the derivative of this equation right here. Okay, so one thing we already know is that the derivative of e to the x equals just e to the x. But since we have a function in our exponent, so we're going to use the chain rule. So derivative of e to the u equals e to the u times du over dx. Okay, so this is a chain rule that we're going to apply to this expression. So let's go ahead and write down what u is. U is equal to this function right here, which is the exponent. So 2x squared plus 3. Okay, so I'm going to go ahead and start taking the derivative here. So we get dy over dx equals d over dx of e to the 2x squared plus 3. Okay, and then dy over dx equals, now we take the derivative here, so we're going to apply the chain rule. E to the u derivative of e to the u equals e to the u times du over dx. So we're going to get just e to the u, which is 2x squared plus 3 times the derivative of this u, which is 2x squared plus 3. Okay, so we get dy over dx equals e to the 2x squared plus 3 times, when we take the derivative here of this term inside, we get 4x plus 0, because the derivative of constant is 0. Okay, so this is our final answer. We get e to the 2x squared plus 3 times 4x. So this is the derivative of e to the 2x squared plus 3. Okay, let's do another example for this exponential function. So we have y equals e to the square root of x plus 3. Okay, all right, so we're going to go ahead and take the derivative. Same thing, here we have to apply the chain rule. So we know the derivative of e to the x equals e to the x. Okay, e to the x, and derivative d over dx of e to the u equals e to the u times du over dx. Okay, so this is the chain rule we have to apply here. So we got dy over dx is equal to the derivative d over dx of e to the square root of x plus 3. Okay, and now we go ahead and take the derivative in next step. So e to the square root of x plus 3, the derivative of that is just going to be e to the square root of x plus 3, this e to the u term right here, times the derivative of the u term, okay, x plus 3, square root of x plus 3. Okay, u is equal to square root of x plus 3. And we go ahead and simplify this. E to the square root of x plus 3 times, here we know the square root is the exponent raised to 1/2, so we have basically 1/2. We bring it down and we have x plus 3 to the 1/2 minus 1 times the derivative of inside, which is d over dx of x plus 3. Okay, so we get e to the square root of x plus 3 times 1/2 x plus 3, and when we simplify this we get negative 1/2 times the derivative of this is just 1, because derivative of x is 1 and the derivative of 3 is 0, so we only left with just 1. So this is our final answer for this. Now let's take a look at another form exponential function where instead of base e we're going to using numbers as a base. So for example, we have 2 to the 3x plus 3. Okay, so we want to take the derivative of this particular exponential function. So one thing that you have to use here is the natural log. So the property of natural log that we're going to use here is that e to the ln of a equals a. So e to the ln of 2 equals 2. Okay, so we have y equals 2 to the 3x plus 3, and then we're going to use this natural log property here, and we're going to substitute this 2 for e to the ln of 2. So we got y equals e to the ln of 2, and that's raised to the 3x plus 3. Okay. Now here we can use the property of the exponent. So if we have a base a raised to the m power, and that's raised to the n power, we can write it as a to the m times n. Okay, so we're going to do the same thing here. We're going to multiply the exponents together, just like here. So we are going to get e to the ln of 2 times 3x plus 3. Okay, now we can take the derivative on both sides. So we get dy over dx equals d over dx of e to the ln of 2 times 3x plus 3. Okay, so I'm going to put 3x plus 3 in parentheses. So, all right. So now let's write it down again. Dy over dx equals e to the derivative d over dx of e to the ln of 2 times 3x plus 3. Okay, so that's what we had right here. Okay, now we can go ahead and take the derivative of this e to the ln of 2 times 3x plus 3. Okay, so again, the property that we're going to use here is we are taking the derivative of e to the u equals e to the u times du over dx. Okay, so here u equals ln of 2 times 3x plus 3. All right, so now we can go ahead and start taking the derivative. So we get e to the ln of 2 times 3x plus 3 times the derivative of u, which is d over dx of ln of 2 times 3x plus 3. Okay, so we get e to the ln of 2 and 3x plus 3. And now we take the derivative here. We can pull out this natural log of 2 out of the derivative because it's a constant and it's multiplying. So it's going to be ln of 2 here. So I pulled out the ln of 2 from the derivative. And then we get derivative of 3x plus 3 inside. Okay, so we get e to the ln of 2 times 3x plus 3 times ln of 2 times the derivative of 3x plus 3 is going to be just 3 plus 0. Okay, so it's going to be e to the ln of 2 times 3x plus 3 times ln of 2 times 3. Okay, so this is our final answer. Okay, now let's go ahead and do one more example with the same form. We have y equals 6 to the x squared plus 1. Okay, so y equals 6 to the x squared plus 1. This is our exponential function. Let me just, I think I made a little mistake here. It says this 1 is in the exponent, not in the, so x squared plus 1, x squared plus 1. Okay, so that was a mistake I made. So this 1 is in the exponent. So again, we're going to use the property of the natural log, that e to the ln of a equals a. So e to the ln of 6 equals 6. So we're going to go ahead and make a substitution for this 6 here. So we got y equals e to the ln of 6. Okay, so we just substitute e to the ln of 6 for 6 because that's equal to 6. And the exponent is x squared plus 1. And now we're going to use the properties of the exponent. So if we have a base, a to the m power, and that's raised to the n power. So we can just go ahead and multiply these two exponents together, m times n. So we're going to do the same thing here. We have e to the ln of 6, and then the whole thing is raised to the x squared plus 6. So we have two exponents, and we can multiply them together just like this. So we got y equals e to the ln of 6 times x squared plus 1. Okay, now we can start taking the derivative. Dy over dx equals d over dx of e to the ln of 6 times x squared plus 1. All right, so now let's go ahead and take the derivative. Dy over dx equals d over dx of e to the ln of 6 times x squared plus 1. Okay, now here we're going to take the derivative of e to some function. So we're going to apply the chain rule here, and let me write this down. So if we're taking the derivative of e to the u, where u is some function of x, so it's going to be just e to the u times du over dx. So here u is equal to natural log of 6 times x squared plus 1. Okay, now let's go ahead and substitute this right here into this chain rule. So we get dy over dx equals e to the ln of 6 times x squared plus 1 times d over dx, this part right here. U is ln of 6 times x squared plus 1. Okay, now we can go ahead and simplify it further. Dy over dx equals e to the ln of 6 times x squared plus 1 times, we can pull the ln of 6 out, d over dx of x squared plus 1. Okay, so in this step, I'm just going to take the derivative of this final term right here. So we have dy over dx equals e to the ln of 6 times x squared plus 1 times ln of 6 times, when we take the derivative of x squared, it's just 2x, and the derivative of 1 is going to be 0, so we just left with 2x here. Okay, so this will be our final answer. All right, so we already did the derivatives of two exponential forms. Now we're going to go ahead and take the derivative of logs, which is going to be natural log and the common log. So let me write down the log, natural log function. We have ln of 3x squared plus 1. So this is our log function, y equals this. So now I'm going to take the derivative of this log function. So we already know that d over dx of ln of x equals 1 over x. So if we have to apply the chain rule, then it's going to be d over dx of ln of u equals 1 over u times du over dx. Okay, and here u is going to be equal to this right here, 3x squared plus 1. 3x squared plus 1 is our u. All right, now let's go ahead and apply this chain rule here to this function. So we get dy over dx equal d over dx of ln of 3x squared plus 1. Now we go ahead and apply this chain rule here. So we get 1 over u, which is 3x squared plus 1, times the derivative of u, which is 3x squared plus 1. So we get 1 over 3x squared plus 1 times, and the derivative of 3x squared plus 1 is going to be just 6x plus 0. Okay, so we get 1 over 3x squared plus 1 times 6x, which is equal to 6x over 3x squared plus 1. So this is our final answer. Now let me go ahead and do another example. We have y equals ln of square root of 3x. Okay, so again, we're going to go ahead and start solving this. We already know that the derivative d over dx of ln of x equals 1 over x. So d over dx of ln of u equals 1 over u times ln of u. Okay, so now we go ahead and apply this chain rule here. We get y dy over dx equals d over dx of ln of square root of 3x. Okay, so we get dy over dx equals d over dx of ln of, I'm going to remove this square root and I'm going to put actually the exponent corresponding to square root, which is 1 over 2. Now we can go ahead and apply this chain rule here. So u equals square root of 3x. Okay, so we can go ahead and write this down. Dy over dx equals, so this is going to be just 1 over square root of 3x, because that's what u is right here, 1 over u times, this is du over dx right here. So this is a mistake I made, so make sure we don't do that. So du over dx. Okay, so it's a 1 over u, which is 1 over square root of 3x, times the derivative of 3x to the 1/2. Okay, now this is equal to 1 over square root of 3x times, now derivative of 3x to the 1/2 is going to be 1/2 times 3x to the 1/2 minus 1 times the derivative of inside, which is 3. So that is equal to, we got 1 over square root of 3x times 1/2, 3x to the negative 1/2 times 3. So this is our final answer. Okay, now let's go ahead and do the log function. So we have log of x minus 3, and we want to take the derivative of this function. So we have this is a common log, so this log equals log with base 10. Okay, so the base right here is actually 10, so log with base 10 of x minus 3. Okay, now we convert this common log function into the exponential form using the base of the log. So it's going to be 10 to the y equals 10 to the log of 10 log with base 10 of x minus 3. And here we're going to use the log property. If we have a to the log with base a of some constant c that is equal to c, so similarly 10 to the log with base 10 of some number 5 is equal to 5. So we're going to apply this right here. So we get 10 to the y equals, this whole thing is just x minus 3. Okay. Now there are a couple of ways to start from here. One thing is we can take the natural log on both sides. So we get ln of 10 to the y equals ln of x minus 3. Okay, so we get ln of 10 to the y equals ln of x minus 3, and now we can bring this y to the front because it's the exponent of this 10, so y times ln of 10 equals ln of x minus 3. Now we can take the derivative on both sides, d over dx of y times ln of 10 equals d over dx of ln of x minus 3. Okay, now we can pull this ln of 10 out of this derivative because it's constant and multiplying. Okay, if it was adding, then we don't pull out, then the derivative of that is going to be 0. But since it's a constant and multiplying, we can pull it out. Okay, so we have ln of 10 times d over dx of y equals d over dx of ln of x minus 3. Okay, so here we can use the chain rule here. So we have d over dx of ln of u equals 1 over u times du over dx. Okay, so the derivative of ln of u is 1 over u times du over dx. So let's go ahead and do this. We get ln of 10 times dy over dx equals d over dx of ln of x minus 3. Okay. Okay. All right. So now we go ahead and take the derivative on the right hand side. So that's going to be 1 over u times du over dx. So u is equal to x minus 3. So this is going to be 1 over x minus 3 times d over dx of x minus 3. This is, okay, the derivative of this natural log of x minus 3 using the chain rule. On this side we get ln of 10 times dy over dx. Alright, so we go ahead and simplify it further. Ln of 10 times dy over dx equals 1 over x minus 3 times the derivative of x minus 3 is going to be just derivative of x is 1 and the derivative of 3 is 0. And now we go ahead and divide both sides by ln of 10. We get dy over dx equals 1 over x minus 3 times 1 times and divided by ln of 10. Okay, so we get 1 over x minus 3 times 1 over ln of 10. So this is our final answer. Okay. Now the last problem is going to be also this common log. We're going to have log of 2x squared plus 2 with base 2. Okay. So this is our log function, and we want to take the derivative of this function. So we get we're going to use the same property of the log. So we have a to the log with base a of some constant equals c. So similarly, we have 2 to the log with base 2 of some number, let's say 5 is equal to 5. So we're going to apply this property right here. So we get y equals log with base 2 of 2x squared plus 2. And then we use this base to turn this into an exponential function, and we get 2 to the y equals 2 to the log with base 2 of 2x squared plus 2. So then 2 to the y equals, this is where this property comes in handy. So this 2 to the log with base 2 of 2x squared plus 2 is just going to be 2x squared plus 2. And now we take the natural log on both sides. Ln of 2 to the y equals ln of 2x squared plus 2. Okay. So we get ln of 2 to the y equals ln of 2x squared plus 2. Okay. Now this right here, this is an exponent, so we can bring it to the front. So y times ln of 2 equals ln of 2x squared plus 2. Now here we can take the derivative on both sides. So d over dx of y times ln of 2 equals d over dx of ln of 2x squared plus 2. Now we can pull this ln of 2 out of the derivative because it's constant and multiplying. So we get ln of 2 outside times d over dx of y equals d over dx of ln of 2x squared plus 2. Now here we're going to apply the chain rule. If we have d over dx of ln of u, then it's going to be 1 over u times du over dx. Okay, so now we get, and here we have ln of 2 right here. So we get ln of 2 times dy over dx. When we take the derivative of y, it's going to be just dy over dx is equal to, okay, here u is 2x squared plus 2. So let me write this down. So u equals 2x squared plus 2. Okay. So the derivative of ln of u is going to be 1 over u times du over dx. So it's going to be 1 over 2x squared plus 2 times d over dx right there. Okay. Now we get ln of 2 times dy over dx equals 1 over 2x squared plus 2 times the derivative here is going to be 4x plus 0. Okay. Now we go ahead and divide both sides by ln of 2. So we got dy over dx equals 1 over 2x squared plus 2 times 4x times, or divided by ln of 2. So we get 4x over 2x squared plus 2 times 1 over ln of 2. So this is our final answer. So this video basically covers all the derivatives of the exponential and the logarithm functions. So if you need to review your these logarithm and exponential function derivatives, then this would be a good video to look at and practice. If you like my video, please subscribe my channel. Thank you.